All right, so I'll be going through the memory shortcuts and analogies for acids and bases. So definition of acids. Think of it as like adding lemon into a cup of water, right? So let's say I have a cup of water here, and then I have a lemon. I add the lemon inside, okay? Add the lemon inside. What happens to the water? The water will turn sour, correct? Because the sourness of the lemon spreads throughout the water. So just like lemons, the acids they dissociate or they ionize in water to form hydrogen ions. Okay, so these hydrogen ions they spread throughout the water and they cause the sourness, they cause the water to be sour. Okay, so they dissociate in water to form hydrogen ions which spread throughout the water. So that is the definition of acids. Next, acid reactions and base and alkali reactions. So the memory shortcut is my big car accelerates, MBCA. So M is metal, B is base or alkali, and then C is carbonate. Okay, then we'll move on to A later. So M, B, and C will be for acid reactions. Okay, so acid plus metal give you salt and hydrogen. And an example of the reaction is hydrochloric acid HCl plus magnesium to give you magnesium chloride and hydrogen. Okay, so acid plus metal give you salt and hydrogen. Next, we have B, which is base or can be alkali also. So acid plus base, give you salt and water. Okay, so acid plus base give you salt and water. This is called your neutralization reaction as well. So since we're talking about neutralization reaction, think of it like firefighters, right? Firefighters, what do? They help to neutralize flames. Okay, so think of firefighters as the base or alkali, and then think of the flames as the acid. So the base neutralizes the acid. That's why acid plus base is called neutralization reaction. Okay. Then one example of this is hydrochloric acid plus sodium hydroxide, which is an alkali, to give you salt and water. So the salt form is sodium chloride and water. Then the third reaction will be acid plus carbonate. So acid plus carbonate, you see a carbon here, right? So one of the products will be carbon dioxide. Okay, that's how I remember it. And then in addition to that, there is salt and water as well. So acid plus carbonate give you salt, water, and carbon dioxide. Okay. In the example, we have hydrochloric acid plus calcium carbonate to give you calcium chloride, the salt, water, and carbon dioxide. All right. So there are three products for this one. Then now my big car accelerates. We have an A, right? This A is actually for the next reaction, which is for bases or alkalis. So your bases, right, it reacts with ammonium salt. Okay, A is for ammonium salt. Ammonium salt basically means ammonium compounds. Okay, so your ammonium ions reacting with a non-metal to form a compound, a salt. So your base plus ammonium salt will give you salt, water, and ammonia. Okay, it's similar to your acid plus carbonate, give you salt, water, and carbon dioxide. But this one, instead of carbon dioxide, you get ammonia. Okay, because it comes from the ammonium salt. So the example I give, your alkali NaOH plus ammonium salt. So your ammonium ion is NH4 plus. So the salt can be NH4Cl. So this is your ammonium chloride. Okay, to give you sodium chloride, ammonia, and water. Okay, so these are the four reactions you have to know for acids and bases. Okay, so I went through the firefighter analogy already. Let's talk about strong acids versus weak acids now. Okay, so think about this. Imagine there are two classrooms, right? And each classroom has 30 students. Okay, classroom A are full of hungry people, but classroom B only has a few hungry people. Okay, so ring is recess time. Everyone in classroom A rushes out of the classroom to the canteen. Okay, because everyone is very hungry. They want to quickly go to the canteen and eat their favorite noodles or rice. And then only 10 people leave classroom B. Okay, because only 10 people in classroom B are hungry. Remember, both classrooms have 30 people. But for classroom B, only 10 people leave to buy food. Okay, then the other 20 people, they are just resting. They are tired. They're just resting in the classroom. So what are the difference between these two? Classroom A is like strong acids. Okay, strong acids, they ionize fully in water to produce a high concentration of hydrogen ions. Just like how all the students, right, in the classroom, they leave to go to the canteen. So since all students left, there is like a high concentration of hydrogen ions, and they dissociate fully because all the students left the classroom. And then classroom B is like your weak acids. Okay, they ionize partially in water to produce a low concentration of hydrogen ions. So just like how only 10 out of 30 people, 10 out of 30 students left the classroom, only partial students left the classroom. So only 10 out of 30, that is a low concentration of students. Okay, low concentration of hydrogen ions. Okay, and take note, this same analogy applies to strong alkalis versus weak alkalis. The only difference is instead of producing high concentration of hydrogen ions, it will be high concentration of hydroxide ions or low concentration of hydroxide ions. Okay, your OH minus ions for alkalis. Right? Okay, then the next will be the colors of the universal indicator. So the memory shortcut is Roy goes back Vietnam. Okay, ROYGBV. R is red, O is orange, Y is yellow, G is green, and B blue, V is violet. So as it goes from the start to the end, it gets increasingly more alkaline. So red is when the pH is 0 to 2, it is very acidic. Orange is when the pH is 3 to 4, and yellow is when the pH is 4 to 6. So around orange and yellow, it is slightly acidic. Then green is the original color of the universal indicator. Okay, the color when it is at neutral pH 7, right? Then as it goes up higher, blue will be slightly alkaline, pH 8 to 11. And finally, the most alkaline, which is violet. Okay, the color violet, the pH will be 12 to 14. So this is how I remember the colors of the universal indicator. Okay, and then we move on to the last part, which is the types of oxides. So the memory shortcut is ABAN. There are 4 types of oxides. A is amphoteric, B is basic, A is acidic, and N is neutral. Okay, then I can further classify these 4 oxides into 2 groups. So your first group A and B, amphoteric and basic, they are your metal oxides. Okay, so basically metal reacting with oxygen to form a metal oxide. And then your second group A and N, which is acidic and neutral, they are your non-metal oxides. Okay, so again, non-metal plus oxygen to form a compound. Those are your non-metal oxides. So the thing about these oxides, right? All of them have different reactions. Okay, so let's start with amphoteric oxides. Think of amphoteric oxides like bilingual people. Okay, we Singaporeans, most of us are bilingual people because we speak both English and a mother tongue language. Okay, so your amphoteric oxides are just like us. They can react with 2 things. They react with both acids and bases to form salt and water. Okay, so amphoteric oxides are very special because they can react with both acids and bases, and they are your metal oxides. Okay, and since we are on the topic of amphoteric oxides, let's move on to the only 3 amphoteric oxides you need to know for your O-level syllabus, which is Z. Okay, Z is the memory shortcut to remember your amphoteric oxides. Z is for zinc oxide, A is for aluminium oxide, and P is Pb, which is lead, so lead-2 oxide. Okay, so zinc oxide, aluminium oxide, and lead-2 oxide, these are your only 3 amphoteric oxides that we learn. Okay, so next we talk about basic oxides. Okay, so your basic oxides, they act as a base. Okay, they act as a base. So what do bases do? They can react with acids only, right? They can't react with itself. They can't react with base. Bases cannot react with another base. So basic oxides can only react with acids, again, to form salt and water, which is your neutralization. So remember I said both of these are metal oxides, right? Both amphoteric oxides and basic oxides. So since your amphoteric oxides is zinc, aluminium, and lead-2 oxide, your basic oxide is basically every other metal oxide. So all metal oxides are basic oxides except for zinc, aluminium, and lead 2 oxide. Okay, so we have covered the first two. Now let's move on to acidic oxides. So acidic oxides, in the name itself, they will react as an acid. Okay, so they react with bases only to form salt and water. Again, this is your neutralization reaction, acid plus bases. And then you have neutral oxides. These are neutral, so they don't react at all. They do not react with both acids and bases. So how do you differentiate between acidic oxides and neutral oxides? For acidic oxides, you have like carbon dioxide, phosphorus oxide, P2O5. And then for neutral oxides, you have carbon monoxide, nitrogen monoxide. So they are all non-metal oxides. So how do you differentiate them? Basically, neutral oxides are those with only one oxygen atom. Okay, they are your non-metal oxides with only one oxygen atom. Then acidic oxides, they are non-metal oxides with more than one oxygen atom. So like O2, you have two oxygen atom. O5, you have 5 oxygen atom. So that's how you differentiate between the two. Okay, so you can read these three tips here that I mentioned already. Yeah. If you want to access this document, you can join my Telegram group. It's in the description below, and you can download it for completely free. Okay, so I hope this helped, and I'll see you in the next video.